morning, everybody. Thanks for joining us today. I'm Jeff with D&H Distributing, and joining me today is Roy McLean from Cisco. How you doing?
Jeff. I'm doing really, really well. Glad to be here.
Excellent. And we're here to talk to you today a little bit about Wi-Fi 6. Wi-Fi 6 is a brand new technology, not completely ratified yet, but we're starting to see a lot of products come forward, and Cisco's absolutely no exception to that, that are sporting the Wi-Fi 6 capability. Wi-Fi 6 has a lot of great features that are brought to it with the new technology. Also known as 802.11ax, this technology is really not just about making Wi-Fi faster, but a lot of things that it can do to make Wi-Fi just better in general. And Roy, tell us a little bit about, what Wi-Fi 6 can do.
For sure, I know you nailed it, right? So Wi-Fi 6 is the latest and greatest toy in Wi-Fi, and we've been doing Wi-Fi for a long time. In fact, this is like generation 6, I suppose, but really all the innovation that's occurred over the last few years since Wi-Fi 1 was around has really been about speed and velocity, going faster, right? We went from 1 meg to 5 to 11 to 54 and so forth. All those things are good, but it's just about speed. And while speed is really great, Wi-Fi 6 goes a step further and starts to look at things like clarity, capacity, noise, things like that. So we're going fast, but we're doing a lot more with the time that we're on the air. So just like phones were a long, long time ago, when someone was on the phone, someone else couldn't be on the same phone at the same time. Same story here. When a radio is transmitting, no one else can transmit, right? So making that time super efficient and packing the most amount of data that we can into that packet is really the key. And that's where Wi-Fi 6 shines. It allows us to send a lot more data in the same amount of time.
Yeah, and it's not just about sending a lot of data in, a short period of time, because all the technologies have kind of built on this, but what I've really heard and I like about Wi-Fi 6 is the focus is on density environments. Environments where you have literally thousands of clients in a very small area, and we always had to do crazy stuff like, shrink cells down as small as they would go, just so we could shove as many of these APs in here and everything. But with Wi-Fi 6, you actually have the capability with the multi-user MIMO and the fact that there's 8 antennas now, that you can actually separate and have simultaneous communication going back and forth, because even environments that didn't used to be density, everybody's got 4 or 5 devices now.
Density has changed. Density has changed. It's interesting, even in a small restaurant, let's say you've got 100 people in that room, you've got 100 cell phones. Now rewind 5 or 6 years ago, you didn't have that many people using those devices. They weren't on them as much, right? Screen time's gone way up. Now the propensity to use Wi-Fi, because they're blowing through their data plans, is much higher. So we see a lot more users, and we've all seen this. If you've been to a stadium or a concert, and you try to go on Facebook to post that really cool picture, it's challenging. And there's access points everywhere. And you go, well, when I was here the other day, when it was quiet, I seemed to get no problem. Now we have hundreds of users in the same space, all with fast devices, right? They've got 5 gig, iPhones and so forth. They're capable of transmitting a lot of data. So now we have lots of devices in a dense space, and they all want to go fast. And typically in Wi-Fi today, so Wi-Fi 5 and before, what happens when you put a lot of devices in one space? They all start screaming. They all start talking louder and louder and louder. Say, me, I want some Wi-Fi, I want some Wi-Fi. They all sort of struggle to get some bandwidth. And then exactly as you described, we have to sort of tailor that network to shrink the cell sizes, to make them more efficient and so forth. It's super challenging. Dense environments really, really hard. Wi-Fi 6 basically eliminates that challenge and will completely change the way we view Wi-Fi in spaces like concert halls and malls and things like that.
And I challenge that the whole density environment thing, what we used to look at as, this is a density environment, this is not a density environment, with all these Wi-Fi devices out there communicating now, sitting in a restaurant, mom and dad used to have cell phones because cell phones were crazy expensive and everything.
Right.
Now you're sitting in a restaurant with a family of 6, 7, and everybody has their phone and they're doing the, sit there.
That's right.
Nobody looks at each other. They're all texting each other. Why won't that stop talking?
It's amazing,
and
too.
They're all playing on it.
We look at some of our case study accounts where we're watching small business environments where they've got Wi-Fi deployed, and we're looking at the amount of requests for connection to that Wi-Fi, and it's dramatically increased. Over the last 2 or 3 years, the expectation is that a public place will have Wi-Fi, and it will go fast, and I can onboard myself to it very, very quickly and easily. And that's pushing the venue owners, the restaurants, the concert facilities, the mall, all of those places to really rethink how they've designed their Wi-Fi because the demands of the customer have changed. Their expectations are, I want to get on the network really, really fast. It should be great. I should have a great experience. I should be able to download a video, update my phone, all those kinds of things, and not have any challenges, even if there's 50 other people doing exactly the same thing. And so the expectations of the user have changed, and so the network designs now have to really keep up with it.
Absolutely. And Wi-Fi 6 brings a lot of other features into this as well. We start talking about security, WPA3 as, protection for our networks. We also have a lot of other things, not just moving fast, but let's talk about 2.4.
Yeah.
Because it's something we haven't talked
That's
about
right.
in so long, because everybody kind of thought,
Yeah.
it's dead, it's 5 gigahertz.
That's right.
You
No,
know,
it's
Roy-
great technology, right? So shorter wavelength, so it means we can go through things. I should say longer wavelength, so we can go through things. That means I can get a better reach to my devices. I've got all sorts of other interesting devices that aren't Wi-Fi clients. We've got IoT devices that are on 2.4.
Oh, IoT.
And IoT just opens up a whole new door. In fact, that's one of the things that really makes Wi-Fi 6 and these new access points that we're going to talk about in a couple minutes pretty exciting, because there's more than just the traditional data that we thought we were going to transfer over Wi-Fi. Now we're looking at other devices. They could be thermostats, presence sensors.
Oh,
They
yes.
could be Bluetooth devices. They might not even be Wi-Fi devices. There's all sorts of things coming into those spectrums. So 2.4 getting a refresh, if you will, really is a great thing for design, because that means I can take my 5 gigahertz traffic for those super dense, very high bandwidth clients, and maybe focus that on them, and then use 2.4 for other things, maybe legacy devices, maybe things that are a little further off the beaten track, or maybe that surveillance camera that's out in the parking lot, or some of those things that I can't quite change out. 2.4 is a great solution for that still.
It is, because a lot of things, still use 2.4, and IoT is a big discussion. And now, this is the first time we've had a standard that, is addressing, making 2.4 even a little bit better than it is today. Because, when Roy and I get together, outside of this, we like to talk about IoT and what we've installed in our houses and who's gone the next step.
There may be a little, home automation battle going on.
Yes,
Just
yes,
saying.
there
Yeah, it could
definitely
very well
is.
be.
Who can make the next thing IoT and get it installed and hooked up? So we have a good time with that. But
But you bring up a good point. There's all these devices that we see these in our home networks, right? Our home automation things that we're doing, light switches and light bulbs and so forth. But translate that into the commercial world. A typical commercial building today has more devices that are connected to the network that are non-compute than ever before. So these are devices that are connected to my network, whether it be wired or wireless, but they aren't compute devices. They could be presence sensors, overhead lighting, cameras, a variety, door swipes, those things we all switch our badges over to get into the door. All of those devices are now plugged into the network, either wired or wireless. And it's completely different than it was a few years ago, when really all I had to worry about was servers, laptops, and maybe some iPads and some other things. Now we've got this whole array of other devices that are connected to the network. And that is becoming a challenge not only for the technology to keep up with, good thing Wi-Fi 6 is here, but also for the network administrators, right? Because they're having to manage
yes.
all those devices that are now on the network that they never had to worry
Network admins
about.
are dealing with things they've never had to deal
It
with
is crazy.
before in the past. And, it's only going to get crazier as we get lighting that is PoE enabled and we start to control all those things. So it's really going to go fast. So describe to us a little bit, how the additional speed works. What are we doing? And you always use this kind of
moving
diagram
truck,
of a truck.
I have a my moving
show
truck.
us the moving truck.
Sure. So my moving truck analogy is just this, right? So Wi-Fi is great stuff, and it basically allows us to transfer data from here to there. And if we think about that as, let's just think about moving trucks, right? So moving trucks are my transport, my network packets. They fly around the network. On average, that truck can hold somewhere around 2,300 bytes in Wi-Fi. Let's just say that's the deal. But data on the network from our applications tends to be quite a bit smaller, somewhere down around 350 bytes. So we send a lot of trucks in Wi-Fi 5 and before. We send a lot of those trucks out that aren't completely full. We're sending those packets really, really fast, and we're efficient in the way that we do that.
Yes.
But the problem is those trucks do go out quite empty very
Yes.
frequently. And so what Wi-Fi 6 does is it breaks that traffic up a little bit more and makes sure that every single truck or every packet leaving the access point is completely full. So we've maximized that packet. And that's really, really important, because we're sending basically the same number of packets in the same number of time. But if we can fill them all the way up and make them fully efficient, then we've gained a great deal of efficiency. Traffic tends to be more consistent. I can start to do things with deterministic settings within the access point to really determine am I going to send this packet to that user or this device or whatever it is? I can do all of that a little bit better when the traffic's broken up into smaller chunks, because then I can organize it any way I want.
Because Wi-Fi, no matter how fast it got, we always used to be, we're passing a token around.
That's right.
So no matter how fast we spoke, it was Roy can talk, then Jeff can talk, then the next person can talk, and everybody had to wait in line. But what Wi-Fi 6 starts to do is, now that you have 8 transmit and receive antennas, you can start to separate spatial streams, because most devices are phones. Most devices only have one antenna. So now I can take those extra antennas, that empty space in the truck that isn't being used to communicate at the same time, and now I can use those other antennas to communicate to and from other devices at the same time, which is really one of the big things that's unique about Wi-Fi 6. So now you take that time, you take your truck that might only have been sending a small IoT signal, but now there's 8 other devices that are stacking up on that truck and all being pushed out at the same time. Simultaneous communication, and that's the big part of what Wi-Fi 6 is going to offer. So Roy,
it's
tell
capacity.
us.
It's all about capacity. I mean, the more stuff I can put in that truck, the more enriched that packet gets when it gets to the other end. It's got more data inside it. That means my application can consume it faster. That means my video loads quicker. My applications are more reactive. It also means something else too, and that is, as I'm fighting for that time on the air with the other clients, because we're doing this more efficiently, everyone has a better experience. There's less retries. There's less errors in the network. All of those things start to turn down as well. And one other thing that's really interesting about Wi-Fi 6, and this will change as the clients change over time, because of course we need all the client devices to catch up to the wireless standard, right? So we'll see I think Samsung has a phone out right now that is Wi-Fi 6 enabled. iPhones will come out with that feature over time as well. We'll see the rest of the phone manufacturers and other devices adopt Wi-Fi 6. Once they do, then the access point can talk to those clients and basically control the volume of their speech. And what I mean by that is, if I put 20 clients in a room and they're all fighting for that access point, they just basically keep getting louder. The clients will just keep saying, I need traffic, I need traffic.
Yeah,
and they all start to yell, and the access points try and respond to all that, and you get a ton of extra noise. And so what I equate it to is, imagine walking into a Starbucks and it's packed and there's 20 tables and there's someone at every table. If everyone's yelling, it's going to be really hard for everyone to communicate. But if everyone just gets a little bit quieter and just talks quietly to the person across the table from them, everyone will have a much better experience. And that's exactly how Wi-Fi 6 operates. It can communicate and give priority to a client that's talking Wi-Fi 6 to say, hey, you know what? If you turn down your signal a little bit, if you get a little bit quieter, I'll give you priority on the network. And so that's what Wi-Fi 6 does. It can take that really loud room of all those screaming clients, turn the volume down, and improve the experience for everyone, and improve the performance for all the clients.
Excellent. So, Roy, Cisco makes Wi-Fi 6 access points today?
Strangely enough, we make access points. Oddly enough.
So tell us a little bit, what they're doing with it, what they have out now, and you're offering it at all levels too, aren't you? Not just traditional Cisco?
That's right, yeah. So you'll see it in Meraki, you'll see it in Cisco as well. I'll start on the Cisco side, the traditionally AeroNet, but now renamed as Catalyst. So we brought the Catalyst name into the access point series as well, and you'll see that throughout all of our switches. It's there for a few reasons. One, because of the brand recognition, obviously, of Catalyst, but the other is the operating system that we're connecting it with, right? So the OS that's running inside these access points, very similar to what we're doing with the switches and so forth, the rest of the infrastructure, that all ties together. And if you've heard about iOS XE, or modular OS, you'll see some benefits of that. One of them you'll see in the higher end model, so the 9120, right, has our own silicon RF chipset inside it. Very exciting. We'll talk about that one in a minute. Let's talk about the 15 and 17 first. So we get the 15 as a 4x4, right? So new technology there. The 17 is the 8x8, but this is the pre-standard. So this is the pre-standard access point. The Wi-Fi standards for Wi-Fi 6 aren't completely done yet. And so all of these bits and pieces have to come together before we can nail down a standard. But
so
people have opportunities.
Let me ask you, if it's not quite standard yet,
why build it?
Yeah. Can this go standard once the hits?
We'll find out, right? So we'll find out when the standard is there. Chances are probably so, but we'll have to wait and see how that all comes down at the very end, right?
And when that happens, am I going to be able to upgrade this to?
There'll be magic that will occur. So we'll see what the upgrade paths and choices are. My guess is that, if you're, the only reason to go down this path right now with Wi-Fi 6 is you have a network design, an implementation that needs to be done right now, and I need that 8x8 capability.
Okay.
If you really need that right now, then this is the only way to do it. There simply is no standard version of that yet. So the 9117 fits in that space really, really well. If you want to go to the full standard, you need to wait. Right? So it really depends on what the customer environment is, how soon do they need this deployment, and how necessary is that 8x8. Now, if they do that, if they go ahead and deploy a 17 now and use the 8x8 capability, they'll have almost everything that you'll get in Wi-Fi 6, right? It's just that we don't have that standardization yet.
Sure.
We can't stamp it and say it is the standard, and there may be some small tweaks here and there, some things that may be correctable via software, others that may not. So we'll see what happens with the standards.
So let's talk about the 9120.
The 20. So the 20 is like the Cadillac, and if you know the existing access point series, like the 2800, it's a pretty powerful box and does everything, right? So what's really cool about the 9120, one is the ASICs that we're using. So we're using Cisco ASIC, our own silicon, and what's great about that is the same designs that we've used in the 9200s, the 9300s, and the other Catalyst OS, we have that same level of programmability in the access points. So that means as things change in the future, we'll be able to reprogram that chip to go ahead and do things in hardware that we typically would not be able to do. So,
and are we going to get clean air with that? Are we going to get
clean
mobility
air?
express?
All those cool things will be
All
plugged into that mixture as well. What's also nice about that is just the ability for us to innovate on the platform.
Yes.
Right. So programmable chips, and you'll see this across the board with all of our ASIC enabled technology. Feature sets are changing fast. And those feature sets are driven at record pace, and they're being driven by software more so than hardware, right? So there's some fundamental things about radio sets, obviously, that you have to do in hardware, but there's many things that we can do in that ASIC chip and reprogram it on the fly. So you'll see some new things come out from a programmability perspective. How about just variable radios? Radios that could be 2.4 gig today and 5 gig tomorrow. I can change them.
That was huge. When you can put in a radio and basically say, here's your 2.4, here's your 5 gigahertz, and here's another radio that could be one of many things depending on what's going on in the environment or what you need it to do. It could be another 5 gigahertz radio if you need it to be. It could be a scanning radio. It could help beacon for device location. So it's really cool in all the different things. And most of these access points now have Bluetooth radios built into them. And there's even talk about some of the Zigbee stuff and everything starting to appear.
9120 actually does have Zigbee built into it as well.
For IoT people.
That's right. So for all those little devices out there, and there's some really powerful things happening in those little devices, right? Both in super low energy Bluetooth, right? So sensors that last for a couple of years at a time, which is pretty neat. So a whole bunch of capabilities there. I know I love getting up on the ceiling to change presence sensor batteries, every 3 months. So this would be nice to maybe have them last a lot longer. But certainly in IoT and manufacturing and industrial environments, that's a really big deal. If you can have a sensor that can last 2 or 3 years and be reached by the network,
it's a lot.
It's a huge difference in the level of maintenance. So those are good things. The other thing that's neat about the 9120 is it has a separate Bluetooth antenna. So the antennas for the radios that are in the box for Wi-Fi, you don't have to turn one of those off to turn one on for Bluetooth, which you do have to do in the 17 and the 15, right? So if you turn on a Bluetooth in there, you need an antenna for it, right? So you're going to use one of those. It'll turn into a 3x3 instead of a 4x4, right? So I'm going to take one of those antennas and assign it to Bluetooth. In the 9120, there's an additional antenna built into the box, so I can have all those radios turned on and my Bluetooth and do all that at one time. No degradation on the platform, right, when I turn those other additional features on, which is pretty important, right? Because it's great to have multiple radios and multiple features, but if I start to turn them all on and I degrade the performance, then what am I buying, right? So with the ASIC built in, with the technology that we've developed there, we're able to activate all services with no degradation. Another place that's really kind of interesting too is if I want to do locate on a client, for example, given multiple radios and an access point, I can take some of those and use them for geolocation, just like you mentioned.
Sure.
So not hyperlocation like we have in some of the other access points, in the 4800, for example. I'm sure we'll see that capability get even better.
Well, that's for hospital grade, finding things down to meters. Maybe we're not quite
we're not quite as, we
Yeah,
don't care
don't
quite
need
as
to
much.
go quite that.
What's interesting is if I have 3 or 4 access points in a given zone, now I can use their monitor radios, right, and not take away from the service radios that are actually providing data, but I can use their monitor radios to do locate as well. So it's some pretty neat stuff coming in that capability. Multiple radios give us that
Even
option.
Meraki's in it too, right?
Even Meraki's in the game, and I love the shape of their new access points.
I know,
So,
it's
in fact,
really
both,
nice.
Both
It
sets
looks
have got a
good.
nice shape upgrade, right? So if you remember the 2800s and 4800s, or even the 1800s, they were solid aluminum case, right? Really, really large and quite heavy. And we got a little bit of flack from our customers about how heavy they were, especially when you're hanging them on a ceiling.
Oh yes.
So
Yes,
these guys
I
are
remember
much
some of the
lighter,
old ones.
and you'll notice too that there's more plastic on the outside, but it's dense. It's not like there's no tinny box here. It's a really, really dense product, and it's designed to really take some abuse, right, and really stand up to the continuous use and being on the ceiling in the heat or wherever it might be. There's great technology been put into the heat sink capabilities inside the box. So while we see this nice looking exterior, inside there's a whole lot of heat sinking going on to keep that thing cool, but with no fans or anything like that built in. And remember, power is really important in an access point because there's only so much we can send it depending on the infrastructure, right? So you may have some networks that have older PoE switches that can only deliver 15 watts or whatever it might be, right? So it's not 30 watt standard. That's a bit of a challenge. Now, we can actually support 15 watt implementations by turning some things off, right? So you can't get all of the radios activated and so forth. In a full 30 watt environment, of course you can turn on all of those things. But one of the few vendors though allows you to actually turn a radio off in order to get to that power level that's supported. So anything that we can do to help cool the box, to reduce the number of interfaces and things like that, physical interfaces on the box, allows us to reduce the power budget, which means we can work with legacy networks. And if you happen to have a nice new shiny 9200 to plug it into, of course you can power it full there.
Let's talk about the shiny new 9200s
Sure.
here for a little bit. Infrastructure is important. And when you have a lot of different access points now starting to move a lot of data across, that before it wasn't that big of a deal because I passed the token to Roy talked, I passed the token to the next person. But when we really start to pack that truck at one time, when it's coming in and we have 8 devices all talking at the same time, or 6, or heavy communication coming in, the reality is I actually could push that 1 gig pipe to my access point over the limit. So we got to talk about M-gig technology, 2.5 gigs to access points, or maybe we just go right to 10 gig or whatever. But regardless of that, it's all flowing in now to a switch, and we got to have something that can handle this expanded communication, and the 9200s are it. I mean, tell us
Yeah,
about
the 9200 obviously twice as much bandwidth than its predecessor, the 2960s, double the amount of PoE power, stacking capabilities, so you can stack 8 of these switches together. When you do stack 8, you get 160 gig bandwidth between them, so that's quite a difference. But each and every port connected to that ASIC on the inside, so again, custom silicon from Cisco, and that allows us to do things at wire speed on each of the interfaces pretty much all the time. So another one of those devices where we can turn on all the features, all the functionality, and then not have a concern about, will I degradate performance somewhere along the line?
Yeah, again, when you're starting to move that much data and it's coming from multiple devices, you have to have an infrastructure that's going to be able to handle this. So maybe if you had some of that original AC infrastructure in place, maybe before Wave 2 or whatever, and you thought I can probably get away with this, it's probably time to start taking a look at what that infrastructure is when you go to Wi-Fi 6 and say to yourself, do I have what I need here internally to support the Wi-Fi infrastructure? Because, like we said before, eventually it hits a wire.
Eventually it hits a wire and it's got to be connected, so it's got to have power, right? It's got to have some level of priority and quality of service, segmentation capabilities. We might want to start looking at net flow and traffic on the network, right, to understand what's going on.
Absolutely.
Maybe feed access points slightly different ways depending on what they're doing and where they're located in the building, type of service that they're providing. So all of those things come together. The 9200 and the 9K family in general, what's allowed us to really have better insight into what's going on. Now, with the box itself, its own UI, web UI that's built into the box, it has some great settings for all of these things. So setting for PoE, all that stuff can be done in the UI. Also things like NetFlow. So I can start to identify traffic even in the GUI on the switch itself. So pretty interesting development for these things, but this is what's going to power that next generation network. And as we look at the networks really changing, you mentioned before, people might have access points from previous generations. They do, because there's millions of them out there, right?
Yes.
So we've sold tons of those things. They're in every environment, and they tend to last for a long time. Access points, customers tend to put them on the ceiling, and if everything's working, they're pretty good with it for quite some time until they run into performance challenges.
Absolutely.
And then it's time to really think about it. And if you look at the overall spend in a network, the access points are not your biggest spend, right? You spend more money on infrastructure and servers and a whole bunch of other things.
Core switching and data center.
Exactly.
I mean, there's your big money.
All your big money is spent there. Access points in the grand scheme of things are actually pretty inexpensive. So changing a few out in areas where you really need them, it doesn't mean you have to do everything all at once. But if you've got a cafeteria, if you've got a meeting room, if there's a presentation space or whatever it might be where you're going to have a density of customers, or density of clients rather, that's a place to deploy some Wi-Fi 6, right? Get that put in place. And it can be part of that slower migration. I don't have to do all of my access points at once. I can do those dense area ones first, and then consider what I'm going to do with my infrastructure.
And the beauty of it is Cisco also has a full line of controllers all set up and designed to operate with the brand new Wi-Fi 6 access points and give you that increased throughput and give you all that functionality and control that you're used to seeing and have grown to love from traditional Cisco solutions that use controllers, as well as the Mobility Express built onto it. So with that said, I'd like to say, thanks very much, Roy, for coming in and having a really good discussion with us on Wi-Fi 6 and some of the things that Cisco's doing with it. Again, in another year, when this starts to come to fruition and you start to see clients out there, client devices that are running Wi-Fi 6, you will really start to see some of these cool density situations come to fruition with what Wi-Fi 6 can do. So again, thank you very much for coming in.
Having me.
Always good
Appreciate
to see you. Please stay tuned afterwards for the Q&A. Roy will be with us and we can answer any questions that you have on Wi-Fi 6 or what Cisco's doing with Wi-Fi 6. If you have any questions, feel free to reach out to us anytime at Cisco Support or Cisco Specialist at dnh.com. Thank you very much and have a great day.